Good morning or afternoon. Today is November 4th, and we are writing parallel and perpendicular equations. So we're looking at parallel and perpendicular lines. So let's zoom in on these notes here. Parallel slopes and perpendicular slopes. So before I go in and write those definitions, are not straight lines. My hand is not that steady. But those are what parallel lines would look like. And they are right next to each other. They could be really far apart. But the point is that their slopes are exactly the same. So their slopes are exactly the same. They have to be the exact same slope. It cannot be that they are close enough. It cannot be that they look like they're the same. They have to be exactly the same. And then for perpendicular slopes, we would have lines that meet at a right angle, kind of like our x and our y axis do. Well, not kind of like, exactly like our x and our y axis do, where they meet at a right angle. Perpendicular slopes will be opposite reciprocals. So you'll flip it and then make it negative if it's not, make it positive if it's negative. So whatever it is, it's going to be the opposite sign, and then reciprocals, which means we're going to flip them. So identify the given slope and the point. Identify the slope you will use. So whether it is a perpendicular or a parallel line, you got to know whether you're going to flip it or you're going to keep it exactly the same. And then write the equation in point-slope form, distribute the slope, solve for y, and then put it in the slope-intercept form. So we did this a couple days ago when we did the first writing equations day. Sorry, I couldn't think of what it was called. The first writing equations day, we looked at how to write it given point-slope form and then how to get it into slope-intercept. So all of that we've done before. The new part of this is identifying the slope and then knowing which one we're going to be using. So right here, this is our point slope. And this is slope-intercept. So on example 1, it says write an equation that is parallel to y equals 2x plus 2 and contains the point 4, 6. So parallel is my key word here, which means same slopes. And this is my slope right here, that 2. It has to contain the point 4, 6. 4, 6 is my x1, y1. So y minus y1 equals m x minus x1. So y minus 6 equals, my m is going to stay the same, so 2x minus 4. So that's my point slope, and now I need to go into slope intercept. So I'm going to distribute this 2. So y minus 6 equals 2 times x is 2x, 2 times negative 4, negative 8, add 6 so we can solve for y. Y equals 2x minus 2. Once y is completely by itself, that is my slope-intercept form of that line. So we see that they have the same slope, but they have different y-intercepts, so those would be two parallel lines. Example 2, write an equation that is parallel to, so same slope, 2x minus 4y equals 8 and contains the point negative 8, negative 2. So this is in standard form. So in this case, the first thing that I need to do is change this to y equals mx plus b. So change 2x minus 4y equals 8 to slope intercept. That way I can take the slope out of there, because right now in standard form I don't know what my slope is. So 2x minus 4y equals 8, solve for y. So I'm going to subtract 2x from both sides. I get negative 4y equals negative 2x plus 8, since it's a positive 8. And I still need y by itself, so I'll divide by negative 4. And I get y equals negative 2 divided by negative 4 is a positive 1/2 x. And then positive 8 divided by negative 4 is a negative 2. So that's the original equation. I still need to find the new one. So this is my slope. I'm keeping the slope the same since it's going to be parallel to that line. So y minus y1, y plus, well, let me go step by step. Negative 8, negative 2. This is x1, y1. So y minus y1 equals m x minus x1. And my m is 1/2. Y minus negative 2 equals 1/2 x minus negative 8. So we just plugged in our m and our point into point slope. Change those double negatives. Y plus 2 equals 1/2 x plus 8. And now distribute this 1/2. Y plus 2 equals 1/2 times x is 1/2 x. 1/2 times 8 is half of 8, which is 4. And then I need that y by itself, so I'm going to move that 2 over. Y equals 1/2 x. 4 minus 2 is 2. So I have y equals 1/2 x plus 2. It has the same slope as that original problem, so it is a parallel line. Now in example 3, we need to find an equation that is perpendicular to this line and contains the point negative 2, 0. So perpendicular means my slopes need to be opposite reciprocals. So I'm going to take this slope, so my original m is negative 1/3, and that means my new m, the one I'm going to be using, is going to flip that, so 3/1, and change the sign. So since it was negative, now it's going to be positive. 3/1 is the same thing as just saying 3. So the new slope that I'll be using is 3, and this point is my x1, y1. So we're using point slope, y minus y1 equals m x minus x1. So I'm going to use m2, just so it's clear since it just says m. Y minus 0 equals 3 x minus negative 2. I see that I have a double negative, and I also have a minus 0. So I don't need to write plus or minus 0 ever. So this is just y equals 3 x plus 2 in the parentheses. And then I'll distribute that 3. So y equals 3 times x is 3x. 3 times 2 is 6. Once it's solved for y, there's my equation, 3x plus 6. And that would give me perpendicular lines. Now in example 4, same thing. We have a perpendicular line that we're trying to find. But again, like on that second one for parallel, we're in standard form. And it contains the point -12, -6. So first thing I'm going to do is find the slope of that line that I'm given. So x plus 4y equals 12. I'm going to solve that for y. So I'm going to move that x over to the other side. I get 4y equals -x plus 12. Then I'll divide everything by 4. Y equals, and I have -x divided by 4. Remember that whenever we don't see a number in front of x, it's a 1. So that is a -1x divided by 4, which means I have -1/4 x. And then 12 divided by 4 is 3. So -1/4 x plus 3, which means my original m is -1/4. I'm going perpendicular to that. So my m2, we're going to flip it. So 4 over 1. And since it was originally negative, we're going to make it positive. And 4 over 1 is just 4. So now I have y minus y1 equals m2 x minus x1. So you'll never see it, most likely, with an m2 in there. I'm just doing it since I'm showing you that the m is changing. We're not going to keep the m the same anymore. We're going to use the second m that we found, which was the opposite reciprocal. And so my x1 is -12, and my y1 is -6. So y minus -6 equals 4 times x minus -12. So I need to change those double negatives, distribute, and solve for y. So y plus 6 equals 4 times x plus 12. Y plus 6 equals 4 times x is 4x. 4 times 12 is 48. Subtract 6. And y equals 4x plus 42. So that line would be perpendicular to x plus 4y equals 12. So these were our notes for today, and then make sure to watch the second video for the homework problems.